All right. Well, today is the 26th of January, and we'll be wrapping up our review of the final student learning objectives in Module 1. You may recall that we scheduled a stop on this screen in one of our previous sessions, I think the last one. And we told you that it was important for you to know each of these because they're significant. And one of the most important things to know in this list is that the European Union has recently adopted general data protections, right? So these are requirements by the European Union, and they're actually stricter than US law. Now, why is that significant? It's about jurisdiction. If you are conducting a forensic analysis or review, whether it's informal or formal, and it crosses over into another island, up or down island, and those islands have European Union associations like French, Dutch, and so on, then those things come into play. And it's important to understand that European requirements with regard to privacy, with regard to protection against unreasonable search and seizure, and so on, all of those things parallel, but in some cases exceed the protections that the patchwork of US laws have provided. So when you look at, the Computer Fraud and Abuse Act, if you look back in 1980s, a gentleman by the name of Morris, who worked at Cornell University as a graduate student, created the first infamous, one of the earliest and most infamous afflictions, the Morris worm. He created a computer worm, and it propagated way beyond expectation, and Morris ended up being prosecuted under the Computer Fraud and Abuse Act that occurred around that same time frame. He ended up on the radar and was actually put in jail for his actions, right? So those are things that are good to know. The fact that seizure of documents, right, can be disqualified, that also applies to digital records. And that went all the way to the United States Supreme Court. Any questions about this and the GDPR and EU? I just wanted to call that out so you're aware. That's European Union. Does anyone have like friends and family in the British Virgin Islands or Down Island?
Yeah.
Okay. So if you were assisting, just casually assisting with an informal analysis, right? Hey, my system blew up. And you were doing this for somebody in a different jurisdiction, that's just important to know, right? It's just good to understand that, right? So when we talk about a tipping point, we're talking about, when we talk about a tipping point, we're talking about this trigger that brings into sharp focus, there's a harsh reality that hits, right? So forensic process can discover and instantly change the scope and intent of an investigation. So it is important to understand what and how to do and where the boundaries are. You need to understand, even for informal investigations, if you suddenly encounter child pornography, that's an all stop. The reason it's an all stop is that child pornography, if left unreported, the failure to report child pornography is a felony. So you go to jail. If it turns out that that child pornography surfaces later on and you discovered it previously and didn't say anything, you're required by law to report that. And it's criminal and it's serious and there's no getting out of that. And those kinds of things happen, right? So you do need to understand the finer points of the Fourth Amendment. So if you were in a case where the subtleties of the Fourth Amendment were not being observed because it's an informal thing and nobody's really thinking about it, and then suddenly, here's child pornography, those dynamics can affect the outcome of a case, right? So what are we saying? It's not uncommon for evidence to be excluded because, things were encountered or discovered and the stage wasn't set properly in the first place. Now, I wanted to talk a minute about network and other elements of digital forensics when you're doing the baseline. In your solution, you are collecting artifacts to establish a baseline related to your network activity. Yes? Does everybody know what I'm talking about here?
Yeah.
Okay. And if I'm not mistaken, you're supposed to capture the output of those commands to a text file. Is that right? Or is it a screenshot? Which?
I believe it's a screenshot, I think. I can't remember.
The directions didn't specify. But I think if we're following the previous past things we did, we always did it to a text file. Also, the study guide tells you the command you enter prints it out to a text file.
Right. So it tells you to follow what's in the study guide, and what's in the study guide captures to a text file. That's a good practice. And it's a good practice to follow faithfully because conditions can change in an instant, and you can be in a situation where you're like, wait a minute, I really don't get, I thought my eyes deceived me. There is, and I'm trying to find this right now. Let me do a little bit of fishing here. I think it's in this course. I'm going to forward you an email message I sent to my son. There were 2 YouTube videos where somebody with a synthesized voice was telling someone how to set up a VPN. And when I started watching it, I thought, oh, I got a bad feeling about this. So this individual was talking about how cool it was. And yeah, I'll find it. Yeah, I'll find it. I either sent it with my personal email to my son. My son works as a cybersecurity analyst. He's a senior analyst with a company that basically collaborates with Department of Defense companies and a whole variety of interests. And essentially, he runs into this kind of thing all the time. But the point is that it's not uncommon for individuals to follow the steps of a YouTube, and then they're in hot water very quickly, and then they undo it. So in a network environment, you can see changes play out very quickly, and it's best practice to capture that to text files and then do subsequent iterations of the text file. So when I say subsequent iterations, what I mean is you could do this, and you could put this in the temp file, and you could say and then the next time you do it, it's .2, right? And then later on .3, .4. It's kind of a running log. It's easy to do this in Linux from the terminal in the same manner. So essentially you have a way of comparing changes. And because you can repeat commands with an up arrow and make quick changes, or you can script this where it loops through, you can do it at intervals for fast changing situations. You don't have to do it manually. That's a good way to go. So it's always important when you're trying to get a baseline, though, especially for networking, that you close all the apps, repower the device or system before checking the baseline criteria. Here is a classic reason why. I have instructional interests. I have 4 different pages open in Edge. In Google Chrome, I have 2, but if I kept my browsers open and kept engaging different classes, different needs, by the end of the day, I would have umpteen different tabs, right? And each of those have network connections. In particular, in this case, I'm using the Chrome Remote Desktop to interact, and there are ways to establish connections with Chrome Remote Desktop where you have open access to send and receive files, right? Does everybody see this?
Yeah, you see it.
Yeah, that's also true for Remote Desktop, Microsoft Remote Desktop. So if you're using Microsoft Remote Desktop or using the app, right? So you're using the handy dandy app that's further down here. Basically, I've got it in here somewhere. Essentially, you have network streams and you have network activity across ports that change very rapidly with regard to NetSH and NetStat, right? So there's a lot of different things that can happen when people are accessing things remotely, and it's not always through a VPN, right? So those are considerations that you need to be aware of. Now, one of the best ways to progress with, or another way to frame a methodical approach to capturing baseline, is to reference the John von Neumann model, right? So even though it's a graphical model, you can think in terms of the different hardware components. And as you're capturing details about your baseline data, you can basically move through that von Neumann diagram from component to component and then capture relevant activity, okay? And that's easy to do once you're inside Task Manager and the Performance tab and the memory and disk and Ethernet. So that's just one way of using a simple diagram that everybody knows well to sort of remain consistent about how you're inspecting and referencing baseline data. Consistency is the key. But there's also another aspect of forensic analysis. It's called the double back. Has anybody ever heard, or has anybody ever seen something in a movie where a person is making their way through a countryside and they're trying to evade or shake someone off, they think they're being followed. So they do they pull a stunt called a double back. Well, that's one way to describe it. The intent
Is that like I think I know what you're talking about, where they pretty much either take like a false turn or they appear like they're going in a direction, but they know that it's not the correct direction that they're going, to pretty much be a bait and trap for the person who's following them.
Yeah, basically a person, if somebody is tailing and surveilling an individual, whether it's in a jungle or it's an urban setting or it's in a shopping mall, one of the tricks to shake off a tail is to suddenly reverse course or to do something unpredictable. So where are we going with this? Method and consistency is certainly a best practice, but it's not a bad idea every now and then to just randomly check something that's later on in the process. People who are trying to avoid detection are often counting, just as we know their tactics, techniques, and procedures. You know, it's kind of like their footprint of it's their pattern of behavior. It's like a fingerprint. Those kinds of things can be, that predictability can be leveraged by the forensic evidence expert, right? So you can check on wireless activity as soon as you connect to a Wi-Fi network, in the middle of a Wi-Fi connection, at the end of the Wi-Fi connection. You can just spontaneously do some things, and you might be shocked to find that there's stuff running in your system tray. It just has a mind of its own, and it's often yoked by malicious actors, right? So I never will forget. Everybody familiar with TeamViewer?
Yeah.
Yeah.
I once published a policy and a warning to all my IT staff. At one time, I had like 15 to 18 people reporting to me. Okay. Full-time and part-time. But the 20, actually it's more than that. So there were 27 people reporting at one time. 20 of those individuals were half-time interns. So they worked 20 hours a week. So I had 25 to 27 people on the roster at its greatest point at my former post. And we had a cybersecurity project that was federally funded. And each of those interns was in the mix with the IT department. They were learning cybersecurity principles, but they were also learning how IT infrastructure operates. So it was actually a pretty cool thing. I put out a notice that said, if I see TeamViewer on any of your devices or any of your screens, personal or owned by the college, you are fired immediately. I will terminate you. You won't know what hit. Security will be waiting with a cardboard box. They'll escort you off the property. You'll be done. The reason I say that is TeamViewer was a popular tool for some of our students, but also some of our IT staff. And they loved the fact that it was free, that there was a free version. And the free version was clearly stated in the EULA that the free version was only allowed for private personal use, not for business purposes. And business purposes required a license, $1,000 license. And I called them to ask if we could get an academic license, and that we could, because it just seemed to me that even the academic licenses were cost prohibitive. They were in the stratosphere. It's like, who would pay $1,000 for a single user license to use TeamViewer professionally? That just seems fishy to me, right? So then I started calling the headquarters and found out nobody's answering the phone. Then I found out it was in Eastern Bloc countries close to Russia, right? And East Germany. And there was a number to call in East Germany. Well, ich kann ein bisschen Deutsch sprechen, ne? So I lived for 3 years. Habe ich für 3 Jahre in Deutschland gewohnt, right? So for 3 years I lived in Germany. And I called. And nobody was home. Then I did some other research and found out that 400 million at that point in time, and this is like 12 years ago. At that point in time, 400 million copies of the free TeamViewer had been downloaded. 400 million. What happened next was amazing. TeamViewer was active in the system tray. And while I was doing a presentation and conducting some basic research on TeamViewer, TeamViewer accessed my Outlook contacts, opened them up on screen, and started browsing my contacts. On screen, live, in the middle of the demo. Later on, 6 months later, I conducted a network forensics class here at the University of the Virgin Islands. One of the capstone projects for CSC 443 was to perform simple GRC shields up. And what we discovered is that TeamViewer was shielding ports in a certain range. So whether the firewall was engaged or not, the activity across those ports was obscured by TeamViewer. One of your predecessors here at UVI, one of our concentration, one of our computer science graduates with the concentration in cybersecurity, caught this live and captured in GRC Shields Up a trace of green shielded ports when all the firewalls were turned off and all the other ports were blue. We did NetSH and NetStat and suddenly found out, wait a minute, that's TeamViewer. Why would TeamViewer want to screen the ports on the network, whether the firewall was working or not? Well, that would mean their screening activity, right? So does everybody understand what I'm talking about here?
Yeah.
We had
Yeah.
one chance. We had one chance to do it. The student caught this live. We captured it together. We had one chance to document this is what was happening with TeamViewer. I still have that data. I'll be happy to share it if you're interested. I'll show you the screen. It's pretty amazing. But TeamViewer is supposed to be one of those handy dandy helpful tools, right? Runs in your system tray. So baseline criteria is really, there's a lot more to it, and you have to be methodical about, okay, why do I have this running in the system tray? Do I really need this? Why is my media audio control panel running in the system tray? Are there any automatic update mechanisms in any of these, right? You'll find a lot of software has automated like update patching and fixing kinds of things. So baseline criteria extends much further beyond what we're doing in our solution. Because when you're in an organization like the University of the Virgin Islands, essentially you can extend the same use of the same tools, except you're doing it in a corporate environment. The larger the network, the more data you have for a baseline. And it's important that the nature of the network you're connecting to makes a big difference. In particular, if you're connected to Bucks Wi-Fi, you're sitting on a public IP address. So there are some things that you have to do a little differently because you're on a public IP range instead of a private. And so you have to kind of understand some things you would not want to perform for a baseline because you're out on a public network instead of a private network. And those are important considerations for your methods. Are there any questions about what we just shared?
What would be some of those things that you'd have to do differently?
Okay. Well, first, I'd like a volunteer. Here is where I'm sitting right now at my home office, okay? So I'm going to stop sharing. I'm going to pause. I'm going to ask for each of you to pull up an administrative command prompt, and then I want you to enter just ipconfig, not the whole enchilada, just the basic command. And then we're going to compare screens, okay? Now, if you're sitting in the class on a smartphone, in the next 2 minutes, I want you to get a screen up, your laptop open, or a tablet. I want you to do something, okay? We'll be back in 2 minutes, and I'm going to answer your question, Jadel, okay? All right, please stand by. Thank you, each of you, for sharing your network, just a glimpse of your local network environment. And just remember that when you're dealing with a public IP range, you have to be a little more careful about what you're doing to capture a baseline, especially if that involves capturing a listing of connected devices that are normally on your network, and you're using Nmap with very basic settings, unintrusive settings. It's also a good idea on each of the different devices connected to run netstat and netsh and compare the outputs between devices, because you may find that somebody has an app and on your system you don't, and there's a tremendous difference between, you know, the one tablet and your laptop. And those are, so benchmarks are not only important for your system, but other connected devices in your network environment. So a lot of times when people are working forensics, and in particular network forensics, they neglect the connected devices in the environment in that assessment. And that's an important aspect about how gifted do you want your outcomes to be, or how blessed do you want your outcomes to be? A quick example would be my LG Smart TV. I have updated the firmware in my LG Smart TV no less than 3 times in the last 9 months. And when I did some research on why I needed to upgrade the firmware, it turns out that, wow, the network environment on that Smart TV is terribly exposed. And it's usually something that appears to be innocuous, like online help. Here it is on the remote. I can just click here and now I'm off somewhere in another system and I'm connected in a weird fashion to something else. Except the connection is like, I don't know, unprotected. It's wide open and there's stuff that's going back and forth between my smart screen TV and some third-party system on the other side of the world. Does anyone know where LG is manufactured? Anyone? Home office for LG? No? No?
No.
Yeah, okay, so we'd have to have more specific search parameters, but basically, corporate headquarters, let's try that. Corporate headquarters, LG Global. Ah, there we go. So did you know there are some apps on your LG TV, and essentially if you fire up some of those handy features, that there's actually some interesting traffic that starts to evolve on your home network, and you have something in your local network that's connected now to the other side of the planet. And if it's an unconnected, if it's an unencrypted platform on the other side of the world, why do they care? Do they need to protect Do they need to protect the data that involves their devices? Well, here's something to consider. Oh, misspelled it. Mirai. So there was an attack that basically yoked a lot of connected smart devices. And of course, for those of you that are anime fans, yeah, there's some interesting connections to the meaning behind the word. But apart from that, there was malware that infected IP addresses for the Internet of Things, smart devices, right? And this happened a couple of years ago in 2016. They brought down Great Britain, as in all of the internet in Great Britain, all of it. All the internet service providers crashed for an entire day in Great Britain. Then they turned and pivoted to Germany, took out the internet in Germany. For much of the day in Germany, there was a blackout for the internet. It was the Mirai botnet. A couple of days later, Americans were bracing for impact. Mirai pivoted all of its 100 million guns, 100 million devices, and took out a good portion of our internet backbone for about 3 or 4 hours. So by the time they decided to take on a much larger environment, we were bracing for impact and doing all we could to work damage control. They only took out 40% of our internet backbone for a period of 3 to 4 hours, but that's pretty impressive. Okay. What's the takeaway? You want to expand your notion of what a baseline is about, particularly for anything that's connected in a network environment, and take the time to investigate. Of course, the more people depend on the cloud, the more interesting forensics gets, because when you're putting stuff in the cloud, where is that stored? Is it stored in your location, on your devices, across your network?
No.
No. So if you have to do forensics and the back end is, I don't know, a Google data center, that kind of limits your capacity to acquire data. And this is another topic for a full class. We're going to be getting into cloud aspects in the last module of our course, because this is like uncharted territory, and there are a lot of challenges with digital forensics where this is concerned. Okay, but we are going to make brief mention of it here. How about this? How many of you have printers and there's a handy dandy web interface for that printer? Or security cameras that you can view on your smartphone? Anybody got one of those?
Yeah.
Oh yeah. And where is that stored? Well,
Local.
local, if you configure it that way. If you don't, what's the default store for, like, what are the Amazon cameras? The ones that Amazon sell?
You mean new Ring doorbell cameras?
Yeah, those things. If you have a subscription, if you have extra equipment, you can store locally. If you don't, it stores in the cloud. There's a subscription. So, this is our last section, next to last section. Right, so we have been talking, and your solution is giving you an opportunity to apply suitable baseline. So I hope everybody's following the procedures that are listed here. If you have not created a temp folder on your C drive, all you have to do is create a folder called temp to capture this. How do you do that? You open up your system and then you right click and create a new folder or directory, and you call it temp, right? That's all you have to do. You can have a capital letter and still run this command. And it's not a problem because from the command prompt, it's not case sensitive. In Linux contexts, it is case sensitive. So if you create a temp directory to run network diagnostics and you capture that to a text file, you want to be sure that you can write, the utilities can write to that file and that there's, you know, permissions and stuff set up. Let's go back to this. One of the things that is a challenge to wrap your head around is that data files, all data files are containers. They contain ones and zeros. We all know that. But some files are more of a container than others. A .iso file is the digital equivalent of a CD or DVD. So that's where digital forensics takes on a whole scale of other challenge. VHD files, of course, are virtual hard disks, but you can store information inside. You can embed data inside a picture, right? So you can take a JPEG document. It's called steganography. Has anybody ever heard of this before? Yes, no, maybe?
Nope.
Okay.
Nope, I haven't heard of it before.
Well, I think it's a good thing that we're covering this then. Steganography. You can take a picture, a JPEG, and there's empty space in that data. The algorithm used to create that data leaves empty space. Steganography tools allow you to write additional data in the empty spaces. It doesn't show in the image. It does not show in the image, but there's empty space in there. And you can actually protect it with passwords. You can encrypt it. Steganography can, and we cover this in special topics called cryptography. So based on popular demand, if you're interested in learning about this stuff and taking a deep dive and everything that has to do with cryptographic, cryptanalysis, right? Cryptology are the two disciplines, cryptography and cryptanalysis, being able to break the codes, being able to use the codes. And so cryptology could be a special topics course if enough of the students said, hey, I want to finish my concentration and I'd love to have a special topics course in cryptology, which includes breaking codes and using codes, cryptanalysis and cryptology. So those terms are used intentionally, right? Now, steganography. We embed, using an algorithm in the empty space, additional information like text files with secrets or other pictures or data files, finance files, malware, the code for malware, right? You can hide it inside the picture. That's because data files are containers, right? The simple truth is these are containers. PDFs in particular are a special challenge. So PDF has become the universal document format, right? And Adobe owns the intellectual property, which is why Adobe is so thorny about protecting its interests for the use of PDFs, right? And you have all sorts of cheaper, free PDF tools. Well, some of those cheaper, free PDF tools are not so free. The point I'm trying to make is Adobe wants to cash in on your use of PDFs because we want paperless documents. And this has been around for a long time. If you have PDFs those can include payloads. A PDF is basically a container, and inside there is, you know, document content, the letters and characters that form the document, and the formatting. There's coding to preserve the original formatting, right? I don't know if you've ever noticed, but you can take a Word document and then you change it into a PDF and the fonts look different. Has anybody ever seen that? Okay, maybe not. This is where hashes become helpful tools. The file itself, the container itself, may not change. So the hash verifies, oh yeah, nothing's changed. But then inside, what you want to do, all right, so the important thing to understand here is when you're using a hash tool, you don't want to run the hash only against the ISO. You want to run the hash against the contents inside an ISO. Consider this. What do we have here? Anyone?
Windows ISO.
Yeah, it's an ISO. And what is that an ISO for?
So that you can build a virtual machine or have a portable USB with a Windows OS.
Yes, it's the install media for Server 2022, and you download it off the Microsoft software in your My Campus portal, right? If you double click this, it's like opening the CD or DVD, in this case, a DVD. And if I double click it, sooner or later, there's going to be a pop-up that says, do you want to open this or run it, or what do you want to do? And, oh, okay. So File Explorer in Windows 11, there's actually a mounting option. Did everybody see that?
Yeah, I saw it.
Yeah, so it's a little more prominent. When you mount a disk image, ISO stands for, you know, it's a installation object, right? So it's an install disk image. Oftentimes in Linux, you have to mount a disk or disk file in order to access the inside of its contents. So this concept is even more pronounced and more important in the world of Linux, where if you want to examine a disk, in many cases you have to mount the disk before you can access it and then investigate it. The point I'm trying to make here is I can, depending on the properties here, I just want to demonstrate this. Anybody see a new option to add a text file here?
No.
No. No. Even if I do show more options, right? And that's because this file oh, okay. The reason it's appearing like that is I have to eject it. So I'm going to eject this. And now what I'm going to do instead, I'm going to go in here. And now now that the file is ejected, before I mount it, I'm going to look at the properties. And read only is not selected. Okay. If I look in advanced, no, there's nothing in there. Oh, by the way, here's an interesting thing, encryption. We're going to talk about EFS some other time. Let's go to security. I should have full controls over this, so I should be able to do some things inside here. But I want to extend my permissions inside this container to see if I can edit the inside contents here. So I'm going to click on advanced. And well, it's all right. So it's treating this like a single file. And let's open with Windows Explorer. So now, let's see if I can go to properties. Oh, does everybody see the read only?
Yeah.
Okay. I'm going to take that off, hit apply. I'm going to apply changes to the selected item subfolders and files. I'm going to continue with administrative privileges because I'm signed in. It says, all right, it says there are some things that are denied, so I might have to get more brute force about it. Inside support, I can go in here and I should be able to. Now, it used to be very easy to do this. So what we're seeing now is that maybe Microsoft has made some changes to their ISOs so that they're not as easy to tamper with, but you can usually create driver directories, and you can create temp folders, and you can add additional resources when you're installing the operating system, but hackers can also install stuff as a payload. There are utilities inside PowerShell and from the command prompt that also allow you to modify or update the contents of an ISO. So it's important to understand that as time goes on, one of Microsoft's tools is to ensure that you have to know more methods in order to be able to get in here. But it used to be painfully easy. If I take an old ISO from 5 years ago, I can just open that sucker up, add a directory, and then pass it on and say, here, load your Windows with this. Yeah, I have a free copy of Windows 10. Here, just use this thumb drive, right? And that becomes an issue. The other thing that happens too is you can take an ISO, create a bootable thumb drive with it, and then modify the USB, right? So you can do it after the fact. Those are just some things to think about. One of the challenges, one of the biggest challenges, is associated with the contents of container data files and also with the metadata. So hackers love to change the file extension names to obscure. One of their favorite things to do is to take like something that they don't want you to see and just change the file extension, and then it's opened in a different application and it looks like gibberish on screen. Or they'll modify the metadata so that they can delete created when, by, the owner information, that kind of thing. So when you're looking at everything that's related to fingerprints and getting a snapshot of your system and creating a sensible baseline, these are finer points of that process that come into play. And so even with a whole disk image captured, right, you got to be able to validate, to verify hashes, and you got to make sure that your hashing tools are always working. Those are constants. Any questions? We're going to pause for a brief moment and then blitz some stuff on the slides. Any questions? Just remember hashing is incredibly important when it comes to validating baselines and changes and issues. It's like a first line of defense. Please hold a moment. We'll be right back. We do want to briefly highlight some of the stuff in your slides, and in chapter 2, I believe. I'm going to eject this, right? I don't want to be in here anymore. In chapter 2 of your slides, the main focus of chapter 2 is to talk about the applications and the facilities. And this is good material to become familiar with. You don't have to learn and memorize everything in here, but there are some, I am going to move very fast here. So there's just some great documentation about the kinds of facilities you have to have in order to perform in-depth forensic analysis, right? So, and there are helpful resources that stipulate or have standards for how you certify as a forensic analyst or a digital evidence specialist, right? An expert. And there are titans of industry in this discipline. One in particular is EnCase. So EnCase is kind of like the Cisco of the networking world. Has everyone heard of Cisco in the context of networking? Or how about Microsoft in the world of operating systems, right? So you can certify specifically with EnCase, but of course you have to use their software and learn all the ins and outs. So you become well-versed in all that. So there are certifications and credentials that the people have to acquire in order to be credible. And then the facilities themselves, if we go further on, the lab itself, you have this idea of a secure area to do this with. The notion of Tempest, when people are using electronic devices, there's radio emanations, radio waves, and hackers know how to manipulate the data on a device by connecting through radio waves, and they can tell what kind of activity, in some cases, the actual content of what's being entered into or viewed on a device. This idea of Tempest has been around for 30 years. So you have to be able to, in some cases, shield the environment from radio emanations. So somebody can't connect with Wi-Fi, they can't connect with other methods, and some hackers are very gifted. There's very common sense physical interests in chapter 2 slides, you know, about security itself, the use of padlocks and steel cabinets and so on. There is one, okay, so this is one thing I wanted to show you. If you had, if you were a consultant and you were the proprietor or the primary for your consultancy and you didn't have partners or other people, this is the minimum you would need. This is the absolute minimum you would need. You would need a connected internet workstation. You would need a disconnected or air-gapped forensic PC. That concept is really important. It can't be connected to anything else. That's where you do your forensic analysis, because you don't want outside interference to compromise the integrity of your analysis, right? You'd have a workbench where you could do simple things and storage cabinets. That's the bare minimum. Any questions about the bare minimum? If you were your own company. Now, what about larger places? Okay, if you're working for a government agency or a company, you would have several workstations, maybe a bigger workbench, you'd have better storage and more storage, and you'd have several screens that are connected to the internet. Just the same kind of thing, only larger, right? If you are part of a law enforcement agency and you do a lot of this stuff, like there are cyber labs in each of the regional headquarters of the FBI, they have very generous facilities, and depending on, I don't know where VIPD fits in this picture, but it'd be nice to know that they at least have like this much. I would hope that the VIPD would not have that much. But it wouldn't surprise me if the VIPD had a facility like this where there was more than one office. You know, there's a reference library area, and there are a number of these things, and then an isolated workbench area. The workbench area could be shielded. That gets back to Tempest. Any questions about that? Yes, no, maybe?
The last picture you saw is what what Lime Tree has.
Oh, wow.
I've seen there, yeah.
Well,
Except for like the conference area. The
That-
conference table, but everything else is pretty much what they had.
that is impressive. That means they take forensics seriously. So I just wanted to finish. One of the primary drivers for digital forensics activities and careers is this notion of industrial espionage. It is, now that everybody's got their stuff out online, there's a lot of foul play and there's a lot of digital malicious action and intent. When crimes are committed, people have digital tools. So when a felony is committed, law enforcement gets involved with the smartphones and they get proof. But the reality is that there's a whole lot more industrial espionage going on where businesses are stealing trade secrets. They're getting additional information about your company. They want to figure out how to leverage your secrets against you so they have a competitive advantage. It's all about dominating the market and making lots and lots and lots of money. That's what it's all about, right? And the simple truth is, there are as many industrial espionage interests in digital forensics as there ever were hard criminal cases, right? And that's because people are underpaid and they're underappreciated. The main driver for industrial espionage is greed, and one of the things that happens in a situation with an underpaid, underappreciated employee is that the competition finds a way to get through and they dangle lots of money in there. And so the tools, a lot of the tools that you need to be effective for digital forensics in a workplace environment is that you need to be able to trap keywords in email, right? So if somebody's emailing, you'd be surprised at how stupid people actually are when they're paid to betray their employer. Or maybe you wouldn't be, but sometimes people are paid six figures, $100,000 or $50,000 to just pass a little bit of information along. And they do it in the workplace. They act like they're doing their own work and they email it or they put it on a thumb drive, right? So you have to have the tools to search for keywords. And when people are writing copies of that kind of stuff to a disk, EnCase does that. EnCase is amazing. You can't sneeze. If EnCase is active in the system tray in a workplace, people can't do anything without getting caught. So a lot of that kind of stuff is really important. The other reason for mentioning industrial espionage is that as a digital forensics specialist, you need to know the key terms and terminology for the workplace environment you're hired to analyze. Because Lime Tree is a great example, right? Would I be worried about banking and finance terms? Except for the payroll department and the logistics department where there's supplies being ordered. Apart from that, what are some of the key words I'd be looking for in a refinery or a transport business like Lime Tree?
Weekly schedules, stuff like that.
Right, weekly schedules, deliveries, customer orders. right? Customer orders. Oh, customer orders are down, right? Or maybe they're up. The point is that you have to work with the folks you're serving to kind of refine what it is you're looking for, and then that becomes a part of your investigation, right? If you have a suspect, you got to be able to monitor their email and inspect their email. This gets back to having a logon banner where you inform people that, you know, hey, you signed on for this job. We've trained you that we monitor our systems for security and, you know, support purposes. And this is the kind of thing you do, right? Physical access. We've already talked about physical access, haven't we? People, you need to understand, if you have digital assets that are important to your work and those aren't physically secured, you're sitting ducks, right? So we've covered that before, I think. These are things that you ideally would coordinate with your customer up front before you start. But things like incoming and outgoing phone logs, you have people calling down island and it's after hours and there's a pattern of it. What is that all about, right? You have to be able to start with some unusual event and then things are examined from there. And in order to do that kind of thing, you have to be able to have access to those systems. Studying a suspect's work habits, that involves having access to, I don't know, video cameras. So I just have a question. Did LimeTree have like video surveillance in certain areas? Does anyone know if LimeTree or they have like cameras set up in at certain points? How
Yeah,
about
they do. I saw the I forgot what they call it. What is the operations room where they have like a whole bunch of screens just watching the ports and stuff.
right? They watch the ports, they watch entry and exit points, right? So the gates, at a minimum, they watch the gates. So that leads to this, right? Surveillance systems at key locations. In order to effectively defend against industrial espionage and to work effectively in a digital forensic context, you have to have this stuff in the mix. And if that's not a part of the customer's environment you're serving, that's your first order of business, right? You got to be able to collect log data from networks and email servers. You have to be able to discreetly gather additional evidence. You have to be able to coordinate with IT staff with confidence. They can't be a part of the problem. So there are some things, there's some foundational legwork that has to occur before you can do this. You review the activities that you're performing with the management and attorneys to make sure that, yeah, you're not doing anything that'll get you into trouble or the company you serve into trouble. So yeah, these are more advanced details about digital forensic process, and sometimes you're dealing with interviews and interrogation. I am not going to do a deep dive about that right now. We want to wrap this up quickly in the next 60 seconds or so, but I want you to understand that this skill set is actually an important matter of training and an important component. When you interview witnesses or suspects, you could be interviewing what you think is a witness, and it's not. Really crafty digital malicious perpetrators are very good at deflecting the suspicion to some other hapless victim. That's a very common thing. It's like, yeah, you know, she's always in here late and she's complaining about her love life, and you know, and there's weird stuff going on in her system. And then the witness that was tipping you off is the one who planted some malicious crap on, you know, the other hapless victim's screen. So there's an art. This is something we could actually teach in an entirely separate class, time permitting. but it is part of the wheelhouse and skill set. You have to be effective at a certain basic level for interrogations. And it gets back to the original premise. At the very beginning of the study guide, at the very beginning of our classes, we said the best forensic tool is what? By far, what's the best forensic tool you possess? You've always had it. I'll
Your
give you a hint.
eyes, observation.
Yes, observation. And the gray matter between your ears, right? Your own powers of observation are basically, so we come full circle, right? And, you know, sometimes it involves being tenacious. You go back and you think you've seen something and you got to replay the tape. You got to dig deeper. Yeah, here we talked about right block devices. That's something we've already covered. Yeah, an equipment list, lots of, we did say you have to have lots of disks, lots of storage, yes? I'm going to send you a picture of a parallel ATA cable and a disk, so you can see what it looks like. It's really old school hard disk, and in older systems, that was a common way of connecting to hard disks. So you can have some very old systems. Firewire, not so much anymore, but well, actually, there are new versions of Firewire that are common on a lot of digital devices now. SCSI card, this is for servers. So server hard disks were connected through a special interface called Small Computing Systems Interface. It's called SCSI. A lot of this is common sense. In order for you to have the means to perform assessments, you have to have the tools and the same equipment and applications. There is a distinction here between a bitstream copy and a bitstream image. You might want to spend some careful time reading this, but basically one is an entire capture of the hardware disk. The other one is a capture of the logical drive. There, everything's on there. The other one is what's on the drive or logical volume. And that's also called an image. So those terms are important to get straight. And when you're copying the entire storage medium, you're talking about the physical disk itself. When you're talking about an image capture, you're talking about the root partition or the C drive, that kind of thing. Does everybody remember Drive Manager when I was in there the other day? You have hidden partitions?
Yeah.
Okay. So a bitstream copy, this will be our last point. So a bitstream copy of the original media would involve the entire physical disk, but an image would be all the ones and zeros contained within this partition or logical volume, okay? So it's good to have those, it's good to understand the difference between those two terms and to understand the difference between bitstream copy and bitstream image in the way they're used most commonly. Some backup software will only capture a logical volume or a drive image, and there's a lot of backup software that won't catch everything on the disk. What do I mean by that? If I back up my Windows machine, it's going to capture this. It's not going to capture the other volumes or the entire contents of the physical disk. So those are things to consider with your tools when you're talking about data acquisition. You got to know which tools do what, and then you're not limited by those. So yeah, it would be good for you to just review these last few slides here. And we may have a question or two in your module assessment that are pulling from these screens. Autopsy is a particular suite of tools that's now available open source inside Kali distributions. So yeah, we'll actually take a much deeper dive on these last few slides in the next modules. So it's just giving you a case or a taste of coming attractions, the high points. Any questions before we close out today? I think it's probably good to mention that after you do all the tech stuff, right? Your ability to translate the outcomes into lay terms for the non-technical that are receiving your results is very important. It's the last piece of the profession, so to speak. You can be really gifted at all of the forensic work, but if you can't translate it into common sense terms that the people who hire you can understand, then you're not delivering as much as you could in terms of value to your customers. So you always have a chance to, it's called quality assurance. Has anyone ever heard of QA or Six Sigma or lessons learned? When a case is finished and the results are delivered, you have a chance to conduct a kind of an out brief where you examine what worked and what didn't and what you could do better. It's one of the best practices for getting better and better at what you do. That's kind of common sense. That component is a part of best practices for every technology discipline, not just forensics. Lessons learned and the ability to go back and refine and enhance based on outcomes is one of the reasons why we're considered professionals and people pay a premium for our services. So this is how good people get better and the better get to be best. That's just common sense though. All right. One last chance. Anyone have any questions, any observations, any curiosities based on the final details that have been presented?
I think I'm good.
Okay.
No questions for me.
All right. Well, thank you for joining us. This concludes our session and good luck on your first attempt of the Module 1 assessment. We'll see you in class on Tuesday.